Okay, are you ready? No. No. Sorry, you have to be. Let's go.
Hello. The title was inspired by one of my mentors when I was a green small developer. That was one of the first advices I got, and I still think it was a valid advice still. I still think that people underestimate documentation and they don't spend enough time reading it. It's also a good way to learn new things. Just read the documentation. It's boring, I know it's boring, but read it, please. If lazy developers wrote it, there's probably something interesting there. A lot of people think that a good shortcut, read Stack Overflow. It's almost dead, so nobody reads it. But people still use AI. Unfortunately, I have a bad news for you. LLM has a knowledge cutoff. It's not aware of all the latest features in the libraries. So in a lot of cases, to compensate for that, they start guessing to minimize the token usage, or they will start scraping the internet or trying to find a source which is not token efficient, could cost you money, and could take time. What comes to humans? Well, usually when humans read documentation, it starts off with opening a browser, which I don't like. There are good software for that. If you're using Mac, there's a Dash, amazing app. But it's still GUI, it's yucky. I don't like it. I think the terminals are built for developers, and developers use it a lot. And I don't want to live a terminal. I want to use it as much as possible. It's just way more productive and easier to script things with terminal. I think there is a gap, and I've been kind of looking how to fill this gap for a couple of years. And I started this project called Posh2i, and it's finally coming all together. It kind of works all in terminal. There is a 2i interface, directly interface. I want it to run on all the platforms. Now it runs on Linux and Mac OS. It's project aware, so it knows what kind of dependencies you have, and it will show documentation only for dependencies that you actually use and actual versions that you use. And I'm also working on an LLM interface, which is I'm testing locally and have very surprising good results. So please, try it out. If you like it, it's great. If you don't like it, please write to me why you don't like it. I'm working on this very actively. I'm getting subsidized to do this work, and I'll be very happy to fix all the problems. Thank you.
All right, thank you for being here. I'm Piotr Jurewicz, and I work at Arkansas, and today I would like to share with you the project that I have been working on for last 2 or 3 weeks. And I did it for our internal purposes at Arkansas, so it is a kind of our internal Wikipedia. And the outcomes were pretty impressive, so I convinced my boss Andrzej to make it open source, and I managed to finish that change that were needed yesterday, and to prove that it is already generic, I prepared a knowledge graph of wrocloverb conference. You can scan the QR code and enter. So to do it, I just downloaded all the transcripts from last 6 editions of the wrocloverb, and I fed my application with those transcripts. So every ingestion entry in this view is a single transcript. You can see the details. It's nothing fancy, just a raw text downloaded from the YouTube. As you can see, there were 2 extraction attempts, so the first one failed and the second one succeeded. So we can look at the second one. It's extraction of Szymon's stock from last year. As you can see, there are some stats here, how many tokens were used, how much time did it take, how many calls LLM did to our app and in how many round trips. Unfortunately, there is no cost in this case because I was using the bleeding edge Claude Opus 4.7, which is not fully supported by Ruby LLM now. So the pricing is missing. But you can see that outcomes are pretty impressive. So it extracted 28 new nodes and 49 new edges from that transcript to our knowledge graph. And here are the details. So it is a full audit log. And this is how the mine page looks like. So you can browse through different node kinds. They are like categories. And you can go through the whole knowledge graph. It's pretty simple and intuitive. For each edge, you can see all the relations. Bonus number 1, it is all even sourced, so you can rebuild the whole knowledge graph from the events. Bonus number 2, it has already MCP server built in, so you can connect to the knowledge graph from your favorite LLM and ask normal questions, like I did. And I asked what was the most trending subject at last year at the conference, and it responded that it was SQLite based on the knowledge from the graph. So the only thing you need to do with that code base to work with your domain is to set up ontology. Ontology is a set of node kinds and relations between them that are typical for your domain. But code is cheap. Show me the prompt. So here is the prompt I use. It starts with you are an organizational knowledge analyst, and then we pass our ontology to the LLM so that he knows what output is expected and what he can ask for. It is crucial that he can ask for our entities in terms of entity resolution. So if Andrzej were at 2 conferences and was mentioned several times, he is still a single entity in our knowledge graph, which you can check. I have already. And the entity resolution works because of the Ruby LLM tools that I implemented. There are 3 of them. List nodes by kind, which is kind of an index query. Here is the repository. Thank you very much.
Okay, let's go quick. So let's talk about for the open source. So I already gave the talk. It's another conference called Open Source Connect Global. So, but let's go for next. Then this is digest. Do you want to create an open source project? Okay. So because it was open source, but not sure what to build. I think it's many people talking about how to contribute, but it's not many people talking about what. So let's find a meaning problem to solve. Do you know this matrix? It's called Eisenhower matrix. It's about for the categorizing for your task, but essentially it is here. You can use it here. I would say it's a important but not urgent problem. It's a good one because it's often not implemented, but it's worse. And also generic enough, not specific to domains or companies. And also, if you see the another solutions, the existing solution is not the best, then you can see that this is a good reason to build it by yourself. I have a good example, like this I gave talk, this one 2 years back in the Euroco. So generating anonymized database with masking is my open source. And then this is here in short word to preventing a database incident. So here it's important because it can lead to severe damage for the database incident, but it's not often to happen. And there's also another way to solve, let's say, linters. But it was good generic enough because you can see that still be here, like it's ranked top 6% of the daily down ranking as of today. And also, when I see there, so there's non-open source project are following the Unix philosophy or in good quality. When I see there, it's many of our like procedure approaches. If you're interested, the record is available for this particular open source. But another example, this is my friend. Oh, he was great programmer, and he was my ex-colleague as well. He was crazy in that good sense because every month or every 2 months, he made a new open source when he find a problem in the real life. Let's see. When he sees the SQL tuning, and he find out, okay, we don't know where to fire the SQL, so he made a gem. Now it's ready to have this function, you don't need it anymore. Or that he has a problem for the sensitive information for the encryption with AWS KMS, then YAML filed something for the open source. And also here, batch process, like he found it's pretty complex graph of the batch control, and he made an open source it, etc., etc. So he has more like 200 public repository. Not all of them are from him, I think, but it's accumulated more than 2,000 stars. It's amazing. So he was a really good programmer. And another strategy, find your own problem. What does it mean? Follow your passion. You know who, right? He made this. You know why? He loved programming languages. He wanted to have his own programming language. So he was kind of hobby project. You know him, right? It was great talk yesterday, 20 years for JLB. And I asked him, why did you make it? Because he was a Java guy, I think still, but because he said, I fall in love with Ruby. That's why he made it. Another example, you know him. Yeah, he made a very, very famous open source project. And you know another one? Yes, already 2. And you know why he make it? Just for fun. He was for the personal project to understand what the hardware works. This is the whole purpose of Linux. He made it. So let's say for the passion. So let's find a good problem and fun. I hope you have something interested to hear. So and any feedbacks are welcome. By the way, I'm having the fun project with Crystal. So if you have any experience with me, so then please talk to me. Yeah, thank you so much.
So, hello everybody. My name is Alina Lyskova. I'm still a developer and still a Ruby developer. And what I want to say is that I'm not a vibe coder. I can't define myself so, but I use AI on my everyday basics, and that's why I want to tell you about it. Kind of telling about my own problems, but we will see it. So, from my perspective, how every my request to AI Cursor, Cloud, or anybody like that looks like. I prepare an input, give it to the model. Model gives me some kind of output, and then I need to evaluate. So I need to define if this output is really okay, useful, and matches all the expectations, or it's bad, and we need to iterate, and I write him, hey, please fix this or that, and so on. So it's a very long loop. And what is important here? Important here is that the model, it's a black box, and it's not developer, it's not even a Ruby developer, it's just a black box which we can't control. And I actually think that we need to think about it when we are asking any kind of input or any kind of tasks from these models. So what we actually can control? We can control on our input and on our evaluation process. So for example, when I work, I like to give more acceptance criteria, more my own expectations, my own filters and requirements for the outcome. So it will be closer to what I want it to be, and for me it's easier to evaluate small parts of code, not just a huge thousands because, no, you know. So what I also suggest, I suggested to split in smaller parts where you can actually say that this input is really okay and you did everything you could to put it into the model. So let's just take an example. For example, we have a ticket to write a new controller road, and it can be one loop, yeah? We can just say, make this ticket for me, and I'm good. But we can go other way. We can investigate all the cases, and for example, get the cases when it must be not found, when it's unacceptable, and so on. We can run the first loop to get all these cases. The second one, we can make it in TDD, so we can ask the AI to make an integrational test for us for this new road, which we even don't have, but still it will be easier for me to review this test because I know how they should like. And the third, my request will be about implementation this road, and I will be able to evaluate as a code reviewer and by running the tests with which I already know what they have. So even if we take a deeper look to this, the first one is kind of agent, kind of system analyst. The second one is tester, automation tester, and the third one is a dev. But it's easier for me to develop such way because I get a better result with less iterations. So actually that's all from my side.
Hi, yeah, so my name is Tomasz, and I wanted to give like a short rundown of a couple of hard lessons that we've learned maintaining a, let's say, moderately sized Rails application, maintained and built by a team of 15 engineers who were, well, unfortunately supercharged by modern tooling. We all know how it's called. I'm going to try to not use the acronym, although I am from a company called EverAI, and we are one of the sponsors of the conference. This is the last time I'm using this word, so please. Anyway, I think we should rethink modularity and how we do it in Ruby on Rails. And I think this is exactly a topic for this specific conference because, like, since its first edition, as I remember, Wrocław also is conference about different ways of doing modularity than the ones that are default and built in Rails, different than Active Record and Action Pack and everything. There was always exploration of different ways to modularize code and to build different abstractions, from aspect-oriented programming, hexagonal architecture, and so on and so on. Like, if you're old like me and you've been here a couple of times, you probably remember. If you don't worry. Anyway, why modularity is important for us? Well, because humans do not evolve. We haven't evolved in years, and we are our brains are pretty simple. Our brains are optimized to, find banana, find stick, and use one or the other. We can, depending on which paper you read, we can hold 4 to 7 items of knowledge in our minds. Let's call it a cache when we are thinking about something, which means that any complexity in whatever we are analyzing, and this is our job. Any complexity basically throws us off and requires complex techniques to manage it. So, and basically if you look at it, modularity has been more or less like one of the bigger driving forces behind programming languages and techniques. From macro assemblers, where basically there were macros, so pieces of code that were kind of expanded and pasted and given place. Subroutines, libraries, structured programming. It took programming decades to finally get the extras paper that go-to statements are considered harmful, so we should actually structure our code and kind of use go-tos, but in a different way than explicit go-tos. And yeah, then modules, then abstract data types, finally object-oriented programming. There's always functional programming in the background, which also has a different concept of modularization called functions. Also, object-oriented programming works best if you exactly use it as functional programming. So, as pure as possible with as little side effects as possible. Components, design patterns, package managers, microservices, and also modern module systems. Modules used as packages. Here, the word module is not a Ruby module. It's a way of a specific piece of code that you can consider separate. This definition is very fuzzy, and you're going to see why in a second. They all had one thing in common. They came from a very simple economy that was true until, well, let's say 2 years ago. Code understanding by a human is expensive because of the cognitive load, because of 4 to 7 items. We cannot find our ways around very complicated spaghetti. we cannot follow the state changes just by reading. If we cannot follow the state changes just by reading the code, we need to fire up a debugger. If you fire up a debugger, I don't know how about you, but when I fire up a debugger, I know that I'm going to wake up at least an hour later from the session. Like, there's no way to fire up a debugger and be done in 5 minutes. Debugger means basically that, okay, I don't have an understanding of what's going on. All my assumptions were wrong. I need to be a monkey and like start poking with a stick line by line specific code base. So code understanding was expensive. Code writing was expensive. And those modularity techniques all came from this motivation. Those are no longer true. Code understanding, which is basically pattern recognition, is now cheap. And code generation, which is pattern reproduction, is also cheap. But it doesn't mean that everything is still great, because because this way we can generate loads and loads of spaghetti code that interacts with our state or anything in a very weird and different and hard to trace ways, and the systems will fail. Will fail in new ways that we never anticipated because nobody ever thought about it, about how one side effect is going to clash with another side effect. What's still expensive is code reviewing by a human is still expensive, assuming the human actually reviews the code and not just looks around if there aren't any, again, generated code review comments. Shipping code is expensive, deployment and stuff. 1 minute, am I 1 minute? Oh. Okay, so shipping code is expensive because of the time it usually takes, like also through staging environment and also production environment, deploying new code, restarts, and so on and so on. But what's most expensive is downtime. Like if you have like a running business, every minute of your application being down because of some stupid error is a very specific amount of money, depending on your organization, that the organization is no longer making, and also broken trust of your users who might not return or who might look for an alternative if it repeats. And then reverting, which is basically, again, reviewing, shipping.
Yeah, so during the event sourcing talk, I mentioned this. What's happening? So there's a little app that I wrote to build those diagrams. And I was just testing for this lightning talk, and I found a bug, so it might fail now. But basically, you can diagram those little flows, like command A goes to event B, that goes to read model of things, and so on and so forth. And then you can build. It's like Mermaid, like text-based syntax for building these things, and you can do pretty complicated things. And then you can also, there's syntax for the test scenarios that I showed earlier. What's happening? Yeah, so that's actually not what I wanted to talk about. That's the app. You can try it if you want. But this app also has an API. And that API has an open API spec. So the way I built that, a REST API with an open API spec, is this other project. It's a Ruby gem that I wrote. It's called Step. And basically, it's a declarative way to build API, self-documenting API endpoints. So it's basically a one-to-one map to the open API spec, except that you can actually run it as a rack app. So you define a service with some metadata, URLs, and so on. Inside the service, you can define endpoints, and endpoints may have schemas, like a query schema for what the parameters in the URL, or a payload schema for post and post request and update and that kind of thing. And the way it's designed is basically one big pipeline of steps using railway-oriented pipelines. So you can just compose steps one after the other. You can actually have sub-pipelines for more complex things. When you define a schema, that's just another step in the pipeline. So you can choose to, for example, define a schema that will validate the payload before or after some other step for authentication, for example. And then it supports some of the authentication schemes supported by the OpenAPI specification. It does content negotiation, so you can do things like send a JSON request and get HTML back, or send HTML and get JSON back, do file uploads, that kind of thing. And then you mount it in rack, and you get an API, and then you you tell it to generate the OpenAI spec, and you add a bit of, you can use the Swagger tool, which will generate this for you based on the JSON API. And this works. You can actually use this, and because the authentication schemas are part of the specification in my Ruby API, then all of this works. You can pass a token, and it will work. And finally, it has another bit of code to basically take your REST service definition and decorate it as an MCP endpoint. So with this single line, you can turn your self-documenting REST API into an MCP endpoint, and then you can mount it just like another rack application in your config.ru file. And that's it. With one single definition, you have a REST API, you have the documentation of the API, and optionally an MCP server for that API. And all it's doing is taking the different endpoints in your API and turning them into MCP tools. So then you go to Claude or whatever, and you ask it to use the API from, conversationally. So for example, this is one of the models that for the demo apps that I was showing in the morning. I was just basically chatting with my domain model from Claude, which is very nice. And then actually you can ask Claude to read the model and implement it, which is sort of cool. Yeah, that's it. That's the talk.
Okay, so this is a talk about various CSV parsing options. Why? Because I think everybody at some point needed to parse CSVs. And there are some gems that make it faster, but maybe there are some other less conventional solutions that not everybody is aware of. But there's also a meta talk. And the meta talk is that I built this in an hour using only Codex CLI. And my point is, it's easier than ever to create a presentation like that. So what are the different options? This is more or less okay. Hopefully everybody can read it. What are the different options? Well, the standard Ruby CSV, Smarter CSV is the most popular gem, I think. There's Polars and there's DuckDB. I will measure how quick they are, and I will measure how memory hungry they are. I'm benchmarking on a few tasks. One of them is like regex parsing for valid date of birth, and then there's like summing up of amounts, and then there's like scanning for some values. Less important, this is getting weirder and weirder. This is interesting. Oh, wow, okay. Wow, now it's like a scrolling presentation. Okay. So at least it's entertaining. So you can see what it is. It will all be available as well on the GitHub repo. So that should be good. Okay, why am I not? Okay, it's all running in Docker. That's basically the most important thing. There's lines of code, and actually the basic Ruby implementation is the largest. I will give you very quick snippets of what it looks like. This is the basic Ruby. No, this is the basic Ruby. This is the Smarter CSV, and this is broken again. Okay. So this is the Polars implementation. So this is looking a little bit more exotic, and this is the Polars implementation with low memory. Where does it say low memory? Well, it's just a flag, right? And you're trading the performance a little bit for lower memory footprint. Let me see if I can. Okay. Wow. So what is the result? Maybe let's get there. I will go to 1 million rows. You're getting. I know this is kind of funny. The main point is Smarter CSV only gives you a 3x speedup. The Polars Ruby implementation gives you a 22x speedup. And DuckDB, if you want to use that as well, that gives you a 15x speedup. And Let me try to navigate. Okay, I guess what is also interesting is the memory. If I can find the memory slide here. Okay, so the post-load memory on the CSV file itself is 30 megs. And you can see that the peak memory and the post-load memory, basically, the post-load memory is on the Ruby, it's like 400 megs. It's like, why do you need 400 megs for a simple 30 meg CSV? Smarter CSV is like 300. With Polars, it's like 100 megs. And with DuckDB, it's only 90. So like, that's pretty impressive. Yeah, and if you actually want to read this talk, not in a weird, broken format, I don't know what's going on, you can visit the repo. It has all the slides, it has all the code, it has all the benchmarks, and I invite everybody to go there, actually look for it, and find a better and faster Ruby CSV parsing implementation. Bottom line, Polars Ruby, the fastest. I actually used it in production with a lot of luck, parsing like 300 megabyte CSVs, kind of within request. So I didn't even need to do any caching or pre-calculation, like in real time, 300 meg CSVs. So this is pretty impressive. I don't know how many of you have heard of Polars and used it in Ruby. I'm seeing like 2 hands. So that's why I think there's maybe some value in this talk, despite all the chaos and maybe some entertainment. Thank you.
Hi, everyone. I've already failed. More fun is tomorrow, and I'll talk tomorrow. But I have a story of 3 lightning talks for you today. When the call went out, I knew the perfect lightning talk. I had written it. I had delivered it before. It was going to be amazing. Let's take a little sidetrack. We've also talked a lot about Docker today. And about a year ago, I was uninstalling Docker Desktop, and I ran this command as part of the how to uninstall everything that the uninstaller doesn't. Does anyone see the problem with this command? Yes, that's right. The space there means no quotes, which means it ran rm-rf on library caches Docker, and it ran it on desktop. And that wouldn't be a problem if I weren't in my home directory when I ran it. So it blew away everything. I hadn't run Time Machine. I hadn't backed it up. It's all gone. There was just so much lost that day. That was the lightning talk I wanted to give. Okay, so with that gone, let's talk about something else. Another passion of mine is testing, and I just wanted to talk through a really interesting edge case for testing. Sometimes you might find yourself with a method that has something like this, where, here, let's just, okay, sorry. With something like this, or maybe you have like in production, like you're only gonna allow emails from a particular domain. But maybe you're like, you know what, in development, I don't wanna stick to that, I wanna write something smaller. This is just kind of a made up example. The trick with this is though, you can't test the development part, because when you run your tests, you're running in Rails env test. So any special Rails env test or conditional you have in a method and wherever, you can't test that, right? So you're like, I won't test it. I'll just test the part that I can test. Well, I'm here to tell you that you can. In both RSpec and Minitest, I came up with a few little helpers. And they just look like this. So this is Minitest. And basically what it does, it uses a gem called stub any instance. And you basically tell it, yeah, when I'm stubbing environment, development is true, and test is false, and production is already false. And then the same thing, if I want to stub production, I tell it stub production is true, and test is false. And so what that means is, 1, I can test the helper itself. So within a stub environment development block, I can assert predicate that this is development. Without that block, it would be like, no, that's false. You're in Rails env test. And similarly, test and production both say false. And we can also test stub environment production. And so then what that means is when you're actually testing your model, you can do things like a manager in the development environment can have an example or can have an email address of manager@example.com, but in the production environment, they cannot. And so similar pattern then for RSpec. The helper looks a little different. So this is using RSpec mocks with temporary scope, and it allows these to return different values. And so same thing, if we have like a file that raises an error, like this one is supposed to raise if you run it in test, or this method raises unless you're in development. And so you can test that. If you run, let's say, these methods, you see we have here an around example. So if we stub development, then we expect it to be true, and we expect some to raise errors and some not to raise errors. One note on RSpec, in Minitest it's really fast, but in RSpec, I found that this helper slows down the tests that are actually using that block. I think it's because the optimizations around the test environment don't happen when you're stubbing it. But anyway, that's pretty much it. If you ever wanted to test Rails and something else, now you can. Thanks.